Hello everyone, welcome back to my channel. In this video we are uncover something that happens every single time you deploy or interact with the smart contract, but hardly anyone fully understand it. So the question is, how does your Solidity code turn into the raw bytes that the Ethereum virtual machine understand? So today we cover these topics, and by the end of this video you will clearly understand the difference between the abi.encode, abi.encodePacked and bytes, how encoding works during the contract deployment and the function calls, how decoding happens. So let's get started. Our topic. Our first topic is EVM workflow. So I show the one picture and we can understand with that. Here's the picture is showing that what happens when you write the Solidity contracts or any smart contracts. First you write by the contract with the Solidity code with the Sol file. Then the file is compiled, and after compilation they make a two different files, two different things like .abi file and the .bin file. The .abi file, which is your raw byte code. Inside the .abi file or whatever contracts you write, that's raw byte code in this file. And the .bin file, which tells the word how to talk to your contract. After that you deploy deploy contract. After you deploy your contract, then transaction happen and all the data are compiling with the byte code and arguments. After deployment, the EVM executes happen, and after EVM, the contract is going to on-chain, and the call data and the selector argument, and you later call a function. Your wallet again the encode the call, and they're using something called ABI encoding. So encoding is literally the bridge between the Solidity code and the EVM. So after we understand the EVM workflow, now we are starting to making encoding single string contract. How to make? Let's start with the simple single string with the three different ways. So I make it the encoding.sol file, and inside the encoding contract we have to write the some function encode full public pure returns bytes memory, and the return abi.encode, and here we write what we want to encode, like what we want to encode the word. So we are encoding the hello world, so we write here hello. So okay, so first we are encoding the hello. Here we do the public thing so we can see that. Then the other function we write function encode packed public pure returns bytes memory, and what we return abi dot encode packed, and here's the same string hello, because the same string we do the three types. With the same string we do three type of encoding. Here's the third one, function encode bytes public pure returns bytes memory, here return bytes hello. In this first contract we are doing the three type of encoding with the single string. This is a single string. So first we have to compile this contract and the deploy this contract encoding. Here's the deploy this contract. The first is encoding bytes, the last one. Encode bytes is a smaller. Encode full means encode full string, and the encode packed. So the whatever the our answer is, the same is for the bytes and the encode pack, but here's the bigger answer in the encode full. So just we understand this, we can hear the like see that if the encode full and encode string is the same as, if we like here's the changes the name, Like here we want to here we change the name and do the something. This is also our one string. And if we deploy this, okay, first we have to compile and the deploy this contract. Then encode bytes is this full like this way, encode packed and encode string also like the bigger one. So here we write in the shorter format. Encode full shows like that way, that length is 96 bytes. Encode packed is that's a shorter one. Like we also get the short length, that bytes is 5 bytes. Encode bytes also we get in the 5 bytes. Encode string we get in the 96 bytes. So here's the padding is there. Before the this all the things. Here's the number is there. Like here are the number, the before that is the padding. So in this also padding, in this padding, but in this encode packed and encode bytes, we don't get any padding before anything. Only the string, whatever the string we write, that's bytes only. So abi encode hello, like a full string. This is whole like this same. This is the same we have. In this long string, the first 32 bytes is offset and that tells EVM where the data begins. And the second 32 bytes is offset. The length that say how long the string is. And the last is the important, there's the actual data came, this one, the last 32 bytes string. So when we doing encode full or encode string, then we get the long string and they are divided into first 32, second 32 and the last 32 like this way. This is the ABI standard and the safe decodable used in function calls. This mostly used in function call. It's like a letter with an envelope, address and stamp, like this kind of. So that this way, this structure makes abi encode fully decodable and reliable. And after that, we understand like encode full or encode string, how that works. After that, encode packed. Why the packed encoding can be also risky. So here's the now abi.encode packed. abi.encode packed and bytes. Answer is like same, similar one, same the number. It's no changing anything. That is compact and gas efficient also, but there is also the one problem that removes the boundaries between the variables. Like I show you the one example with this. Like if we do this example, the Kachak ABI encode pack AAA and the second string BBB. And the second one is same, but here's the 2A and the ABBB. The number is same, but the string is different. If we make this hash, that hash is also the same hash. So encode packed and bytes both are giving a row. So here the after encode packed and bytes, that compact but risky also, because the encode packed and the bytes both are giving the row bytes like a same number, same bytes. So perfect for hashing or storing, but not for decoding. And after like multi-value encoding, this is the hash collision risk, like a catch-up 256 ABI encode packed AAABBB, and the same is equal to catch-up 256 ABI encode packed AAABBB. If we both give like same hash. Why? Because the without length information, the EVM can't tell where the one string ends and the next string begins. Because same thing will be we do with the ABI encode full. Then they give the different strings. But here's the ABI encode pack. They don't have a length information. So EVM can't tell where one string and the next string begins. When you are encoding dynamic data like a string or arrays, avoid encode packed. It can lead to hash collision and the logic bugs. Never use encode packed with the dynamic type of signature. We write the another contract. We have to understand how the multi-value encoding works. So we write them another contract. The contract name is contract multi encoding lab. And here we write the function multi encode public pure returns same like above bytes memory. But here's the difference between the we return the two strings. Above we write the only one string. Return abi.encode hello and comma world. For this also we can write is the three different type. Function multi-decode. Now we decode also this string. And how we decode it? Like with the use of multi-decode, public, pure returns, bytes, memory, return, abi.decode, multi-encode, multi-encode, and inside the we provide the string, the first string and the second string after the bracket is over. Okay, the multi-decode pure public pure returns string memory. Okay, here we show the two times string memory. And the return abi multi-encode. We are using the decode, but we have to encode this encode. We have to do the decode that. So we write here the encode thing and the string and string. There is a two strings, so we define like that way. Then the other function is function multi encode packed public pure returns. Here we have to write bytes memory. Here we write string memory because the one string and its memory, string and memory. So here we write like that way, and here we have to write bytes memory. And the return is abi.encodePacked. Argument is like hello and the other one is world. We use the same name so we can understand better way. Okay, now we compile the contract and we deploy the multi-encoding contract. Yeah, if I tell you about the abi.bin file, so you can find that file here, abi and bytecode file. You compile like we write the multi-encode, then we get this abi file from here like that. Abi file looks like that way. Here's the in abi file that included the whole code. So here we get from abi and bytecode file. So now we compile the multi-code contract, deploy the contract, the multi-decode. The first is decoding. The hello world decode is happen. Then the multi-encode. This is too much long file bytes. And the multi-encode packed. So they have like a simple small string, small bytes. So if we call the multi-encode, so I get the long structure result. We get a long structure result. And when I call the multi-decode, then multi-decode and it's clearly like write down hello and world. And when we see the multi-encode packed, the merge is both the string. Here's the no two type of different string, they merge the string. If we want to more understandable, we can add one function. So here we add one more function like multi-encode packed and multi-decode packed. So how the decode this and how the decode this. That compile the contract first and the multi-encoding lab and we get the contract. And here's we have a four function. So first we do the multi-encode pack is like that. Multi-decode is properly hello and world that gave a two string. Multi-decode pack, they are not doing the two different string, they are making the one word. And multi-encode it's byte, it's like lengthy, so they have a more bytes and so they gave a structure proper result like hello and world, the two different string. But because the multi-encode packed have a merge the both string, here's the not any define the spaces of that words and anything, so they gave the jointed string like that hello world. So now you understand the multi-value encoding is safe versus risky. Like this is a risky one because encode pack is not, they're making the same string for this both of them. After that we making a one more contract that how the encoding behind scenes happen. So we make one more contract, my contract. Here's the string. The first video and string public name, and the other one is u256 public value. So we defined here value and then make a constructor string memory name and u256 value. So here we define name is equal to hyphen name and value is equal to hyphen value. Here we're missing the one bracket, so that is error happen. We can deploy, first we deploy the contract and we can understand how that working. So my contract deploy here with the name and the value. So I put my name CodeByAnkita and here's the number 100 value and transact. So here's the contract is making. The name we get CodeByAnkita and the value we get 100. So here what happened, like remix compiles the contract. This contract compiles by the remix and that contract byte code. Remix compiles the contract to the byte code. Here's the remix compiles the contract to the byte code. Then the encoding the argument. It's using the abi.encode with the abi.encode. So we can like understand and appends to it bytecode. So we get the CodeByAnkita and 100. Then it's encode the argument. Like we put this two argument here. That argument goes into an abi.encode by these names and it append to the bytecode. The whole chunk, like this whole chunk, bytecode plus encoded arguments goes inside the transaction data field, and that's how the EVM knows that what to store in the constructor variable. And after we like call this name and value, then we get the CodeByAnkita and the 100 both together. That kind of EVM works. So how that like contract work? Remix compiles to the like .bin file and encoding arguments with the abi.encode and appends to .bin file and the same data whatever we return, that the transaction data is like that bytecode and 0x and the encoded arguments. First they are provided the bytecodes. Our next topic is the function calls and the selector and argument. So when we call something function in the like contract and how that argument and all things happen. So for that we have to write a one contract about this function call encode. So u256 public store value. After that we write a function set value u256 new value. Then we make it that public so we can see that, and after store value in bracket store value is equal to new value. So we are storing store value instead of new value. We are like transfer this. After one more function we make function encode set value. We have to encode that also. So encode set value u256 new value public pure returns bytes memory return abi.encode with signature. So here we have to put a set value u256 and the new value argument is new value. So now let's talk about the function call. Every time you interact with the smart contract, your wallet creates a data that look like this way. So we can understand better after we compiling the contract and the function call encode contract transact. Okay, after we compile the contract and we can, here we have to set a value. Before that, store value is 0 because we are already not store anything. So store value is 0. Now we store set value is 42. Set value is happen. Now we can see the value. New value, I put the 52. So here's the, after we compile, we have to deploy this contract, and here our contract is deployed. First we call the store value, and the store value is 0 because we are not storing any value and not providing the default value. So default is the 0. So now we set value 42. So set value over 42. Now we store value, see that also coming the 42. And here's the encode set value. If you want to like how encode this value, then we have to put here also 42. And how that encode works, like that kind of bytes we get. Here we see the input of this. If you can see, the same input we get here also, and the input data also that goes like same input. So here's the how like function data call works. And in that, the first 4 bytes, these first 4 bytes are the function selectors in this whole string. This is the whole string we get from that function call, and the first 4 bytes are the function selector and generated from the function signature by the set value. That is the function, that is a 4 byte, that is a function selector, and this generated by the function signature set value into 56 for this. And the last all the bytes, like last all 32 bytes, and the next 32 bytes are represent the argument, and here the 42 are padded to 32 bytes. 42 are padded with this 32 bytes. This is what your wallet sends the data to the field. This is literally what your wallet sends to the EVM when you click the confirmation to the transaction. And we can see after the transaction we can get like this way to null, or like whatever address we send the transaction, and the data in the here the data inside that byte codes and encoded arguments is all in this data. And the other is a nonce, gas price, gas limit, value, and VRS things you get. Only the data content in this all thing, only the data contains your logic, and everything else is metadata. Your whole argument, your all code is contains in the data field. Here's how the real EVM transaction look like. After you complete the transaction, then the real EVM transaction look like this way. The data field contains everything we have been discussing till now: bytecode, selectors, encoding arguments, all the things. And everything else is a gas price, value, nonce, VRS. That just all about the metadata. We can create one more contract that with that you can understand better. Contract EVM master. In the here we put a event log bytes data string label, and the function we made here, function deployment deploy demo. Function name we put a deploy demo, and that is a public pure returns. So we put a bytes memory, and that return abi.encode. Here I put the code by Ankita, and inside the u into 56 we put 100. So here's the one function. We make it the other function is function called demo. U into 56 x. We have to put the value of x, public pure returns, and bytes memory, and here we return abi.encode with selector bytes 4 and we put a Kachak 256 set u into 56 and argument is x. Like, so you are confusing now after the function finish, like you can understand. The other function is function packed demo. It's like same packed hash. String memory A, string memory B. Here also public pure returns. And here we put bytes 32. Return this Kachak 256 abi.encode packed. Argument is A and B. This is the our EVM master contract. We can understand more better with this contract. So the compilation of this contract and the EVM master contract, we compile and the transact and we can get this contract. First call deploy demo. So here we get the bigger string. So what we contain, we know that let CodeByAnkita and the 100 that string content is this. And now we want to call a call demo. So we put a x, something a value about that. So we put like this value and this also packed like this way. Call demo. With this call demo, you can get this function called bytes. And the encode hash. We have to put the here two name like. So we put same like A and B. But we have to put in the string A, string B. So packed hash. So here we get a packed hash. So it's a clean example of the hashing packed data safely. So here you can understand properly how can will work encode packed hash, bytes, all things work. How that work and how that work in the contract, how that in the function call. Let's recap what we learned. Like we learned the abi.encode. abi.encode is a safe, padded, and the fully decodable string, properly that decodable. And this abi.encode pack. This is the compact string, but with the abi.encode pack, we can get that's a compact byte, but it's a risky with the dynamic datas. And the bytes is just a raw UTF-8 bytes. And the both are same. abi.encode packed and the bytes. That output is the same for both of them. Then we do the deployment with the bytecode and encoded constructor arguments. Then function calls also we do with the selector and encoded parameters, encoded params. Once you understand this, then the EVM becomes the transparent. You can literally read the transaction like the second language. Like you can read in the binary file, you can read here in the abi.json and this bytecode you can read here in this like data input and output. Properly we can see the all data here. Like the same string we can get there also. So here's the now all thing you understand properly. abi.encode pack, bytes, deployments, function call, and never use decode packed for the dynamic data. So I hope with this video you can finally understand the Solidity encoding and decoding, how that works and what is the ABI file and how ABI encode, how ABI decode and ABI encode pack, bytes, all things works, how you can understand. In this video, with the help of that all the contract, you can understand ABI encode pack, abi.pack, decode, how that works in bytes. So now our topic is over. So goodbye everyone. Thank you for watching.